Remember, we were working on an electronic test and assembly, electronic assembly and test system. And we have developed a simulation model for that. But according to the texts, the manager asks us to implement a few changes in the model to make it more realistic and to make it conform to the original system. And these changes that she would like to mention is what? So they are given here. It says, as you can see, periodically the sealer machine breaks down, it says. Okay, the sealer machine breaks down. Engineering looked at the problem some time ago and collected data to determine the effect on the sealer operation. They felt that these failures did not merit any significant effort to correct the problem. However, because they didn't feel the sealer operation was a bottleneck, so actually we know that in our system, so if you remember our system, the bottleneck process was the rework process. The slowest process here was the rework process. But there is a failure problem in the sealer process. The sealer resource, the machine, frequently breaks down, and it takes some time to repair that machine. And according to the data, the observations that they have collected, it says the mean uptime from the end of one failure to the onset of the next failure was found to be 120 minutes, and the distribution of the uptime is exponential. Okay, and the repair also follows an exponential distribution with a mean of 4 minutes, it say. Okay, so we have a resource failure here, and the resource, the sealer resource, the sealer machine. So if we check this resource here, it is called sealer. Okay, the sealer machine here, it experiences some failures. So let's check. So you see we have process here, we have the sealer process, and by the way, we are going to change the failure, or actually we are going to add the failure aspect from the resource module here. So we have the resource module in the spreadsheet view, as you can see. So we have 4 resources right now. The machine that we use in prep A, the machine that we use in prep B, in the processes here, and the machine that we use in sealer process, and the machine that we use in rework process. So here in the sealer process we are just going to right click on that, and we are just going to say edit via dialog box. And when you say edit via dialog box, you see there is a section that belongs to failures here. So by using, again, let me show you from the beginning. Now, if you want to add a failure aspect, okay, a failure aspect to a resource, to a machine, to a resource that you use, then you need to choose the resource spreadsheet view here. And after that, you are going to choose the resource from here. So we are talking about the sealer resource, sealer machine. Now we are going to add a failure aspect to this resource in sealer. So we are going to choose edit via dialog box, and we see a section that belongs to failures here. Now we need to add a failure here. So we say add, and the name of this failure is going to be sealer failure. Sealer failure. And there is a rule here. Now we are just going to choose here, we are just going to choose which one of them. Actually, it doesn't matter which one we choose, because I am not going to explain at this moment the meaning of this, but I am just going to explain it later. So let's just say ignore. Okay, let's just say ignore the failure rule, ignore. I'm just going to explain what do these means in the next application that I'm going to run. So let's just say okay, and okay. Now, actually, we have said here, we have defined that this resource is going to experience a failure, which is called the sealer failure, but we have not defined the length of the uptime period or downtime period for that machine. So basically the parameters of the distribution and the distribution of the uptime and downtime are not defined here. We have just defined a failure name. So where are we going to define the length of these periods, length of these failures? Now here you see we are in the basic process panel. Now we have an advanced process panel as well, okay? And under the advanced process panel, we have a spreadsheet view that belongs to failures. Now, because for a resource you have defined a failure, now that failure is another object. Okay, that failure is another object, and that failure is available to see here. Now you see we have under the advanced process panel, we have a failure spreadsheet. And in that spreadsheet, already there is a failure that is defined, sealer failure. And now we need to change the contents of this cells by again right-clicking on the row, and we are just going to edit it with dialog box. So the name of the failure is going to be sealer failure as we have defined, and the type of it is going to be time. So if the type is count, this means after 100 entities, it is going to break down. And when it breaks down, it is going to take some time to repair it. Okay? So count, so if you define the failure based on a count, this is going to mean after 100 entities move through this process or move through this resource, if they use this resource, okay? Actually, I should not say process, I should say resource. If 100 entities use this resource, after 100 entities, it is going to break down. But instead, the question, the text asks us to define that failure on an uptime and downtime basis. And the uptime is what? Exponentially distributed with an average of 120 minutes. And the downtime is exponentially distributed with an average of 4 minutes according to the text. Okay? Now, I'm not going to explain this. If you want to learn about the last component here, because this is not a part of this application, you can just click on the help here and just click on here to learn details about the uptime in the state only aspect here. Okay, so we are not going to do this. I'm just going to close it, and I'm just going to click on OK. Now the failure periods are defined here. So sealer failure periods are defined here. Now, because in the basic process for my resource sealer, I have defined a failure here. And that failure, if you click on that failure here, it is defined as sealer failure with an ignore rule. And the details of these failures are given in the advanced process panel, under the advanced process panel, in the failures spreadsheet view. I know that it is a little complicated, but object-oriented programming requires this to do. Okay, so we need to model the failure of a resource by defining a failure for that, and that failure is going to be changed, or the uptime and downtime aspect or properties of that failure is going to be changed from the failure spreadsheet view. Why do we do that? Because you can define the same failure to another machine as well. So for example, I have defined a 120 minutes exponential uptime period and 4 minutes average downtime period with, again, exponential distribution for the sealer machine. Now, if someone says that the prep B machine also experiences a similar downtime and uptime period, I can simply use the same failure for that without defining an extra new failure period. I can say here, edit via dialog box, I can add sealer failure at here, and the same type of failures will be experienced by prep B machine as well. Okay, so this is why we need to define the failure periods under a failure name in a separate spreadsheet. Now we have described the failure that the sealer process experiences. Now we are good to go to implement this. However, I'm just going to add another animation here, a resource animation, if you remember. Now, I'm just going to click on that, and I'm just going to add an animation that belongs to sealer resource, and it is just going to be during the simulation. If the sealer is busy, then the light turns green. If the sealer is idle, then the light will be white, and if the sealer is failed, then the light will be red. Okay. So this is the animation that we are going to see. I click on OK. And by the way, we need to change this into a second or minute unit, because if you want to see the changes as soon as possible, then the frequency of these changes, the effects should be as small as possible, but that is going to slow your animation down. But it doesn't matter, because we can always skip the animations once we are bored of observing them. Okay, so for the sealer process here, at the top of the queue, we are just going to see an animation, and as the simulation runs through, we are just going to see when sealer breaks down, and when it is busy and when it is idle. In fact, let's just see it. So with the slowest animation, I start the simulation. So if you remember from the last week, so you see when the idle machine is busy, the light turns green if there is something there to process. And if there is not, it turns white. Now, at some point, you will realize that it is going to turn red, but it has been just 28 minutes right now. You know, the average time to break down is 120 minutes. So let's just make it a little faster. So it is 50, 55, 60. But you know, the average downtime is just going to be 4 minutes. Now, soon you are just going to realize that it is going to fail. The light is going to turn red. So please be careful. I don't know, maybe I have missed one. Let's make it a little faster. There may be a problem in the definitions that we have defined. So let me check failure again. So we have 120 uptime in minutes, and we have 4 downtime in minutes again. And we have this failure defined for the resource in sealer process. The resource in sealer process is what? So the resource in sealer process is sealer, and we have defined the failure for the, okay. Maybe I will change that to that. So let me see again. Okay. So I think you see now, sometimes it turns red. I am going to explain why I have changed it to wait and the light turned red. I'm just going to explain it later, okay? So when the time comes. So again, if you wait enough, sometimes you realize that it turns red. And when it turns red, it experiences a downtime on the approximately, which takes around 4 minutes on the average, but it's an exponential duration. Okay, so let's just stop here. So we have made our first change here.